Activity 2 is the task-based assessment, where you're given some information about an experiment or experiments that have already been carried out, and you have to analyse the data. So the background information for this task goes through the fact that there's a new company, We Just Eat & Co, that have produced different flavours of crisps, and they want to find out how much energy content is in each of the different flavours of crisps. And there are two ways that you can calculate or measure the amount of energy in the crisps. Method 1 is using the calorimeter method. It's a purpose-built device called a calorimeter, and it measures the amount of energy in food. The energy value of a food can be found by burning the piece of food in the calorimeter and measuring the energy that is given out as heat. If you've got a known mass of water, there's a stirrer, there's a thermometer. The food is burnt in the crucible, and there's an oxygen-rich atmosphere here. It's set alight, and the rising temperature of the water is measured when the food has finished burning. The results collected from this experiment can be seen here. You measure the mass of the crisp. It's been repeated 3 times, and the energy released can be calculated using the temperature rise of the water. They've done that for the sausage and bean flavour, cheesy pizza flavour, and chicken tikka flavour. The second method is a method where they use energy densities. So it says food scientists can use the list of recipe components and data from energy densities to estimate a product's energy content. This means that they only consider the digestible components of food in their calculations. So they're using already known calculated energy densities to do their own calculations. Based on their calculations, each of the flavours, which they did once, gave these values in 100 grams of crisp. In this section, you're actually expected to analyse the data, perform calculations, etc. So task A says calculate the energy released per gram. Per gram is in bold, that's really important, obviously. Enter your values into the table below. So here we've got the energy released per gram, and these values were missing from the table initially. You can see we've still got massive crisp and energy released like the first table that we were shown. This energy released is in units of kilojoules, but we need to work out the energy released in kilojoules per gram. So if we take the number of kilojoules and divide it by the number of grams of food, we get the kilojoules per gram. So in this case, where we have to actually work out these values, we would be doing 188.9 divided by 8 grams gives us a total of 23.6. On your calculator, you may actually get lots of numbers after the decimal point, but as all of these values have been recorded to 1 decimal place, you need to record your values to 1 decimal place also. It then asks us to calculate the mean energy released per gram. Now, to calculate the mean, we have to take the 3 readings, add them together, and then divide by 3, and you'll get, again, the mean energy released for the 2 that you weren't given. You add these 3 up, divide by 3, write down your answer to 1 decimal place. You're now asked some questions related to the data. The first question says, state what flavour of crisp would be the best for somebody on a low energy diet. And if we flick back to the results, we're looking for the crisp that had the lowest energy, and that comes out as the spiky chili crisps. It says explain why you came to this conclusion, and as you can see in the data, the mean energy per gram is only 21.9, which is lower than the other 3 flavours. Also explaining that someone on a low energy diet would need crisps that have the lowest energy released. This space here is only needed if you wish to make any other points about the results. You could comment on how accurate the results are, whether they were repeatable, whether they're valid. It then asks us to analyse the data given from the second method. So we have the energy content per 100 grams, and we need the energy content per gram. So if we take this value and divide by 100 grams, we'll get the answer for 1 gram. You can do that on a calculator, or you can use it, do it using any other method that you've learnt maybe in your maths lessons, like this one here. Again, making sure that you record everything to a sensible number of decimal places. The same question is asked of this method. State which flavour of crisp would be the best for somebody on a low energy diet. If we look this time at the energy content per gram, we can see that the sausage and bean flavour crisps are the ones with the lowest energy content. It asks us to explain how we came to this conclusion, and we can comment on the fact that they are the lowest energy per gram at only 21.00 kilojoules per gram, which is much lower than the others. And also again commenting that if you need a low energy diet, you need the ones that release the least amount of energy. We now need to evaluate each of the experiments, and the first question asks how suitable this method was. So looking at method 1 firstly, even though this was a purpose-built device, the calorimeter actually does have some inaccuracies, especially in the measurements of temperature. Were there any causes of inaccuracy? Well, the causes of inaccuracy in this piece of apparatus is that not all of the heat energy from the burning food is likely to be converted or given to the water. Some of that energy may be lost to the surroundings, giving us an inaccurate reading of temperature. Were there any ways to improve this? Well, if we don't want to lose energy to the surroundings, the ideal thing to do is to insulate the calorimeter and put some insulation around it to prevent heat being lost to the surroundings. We could also comment here on using a data logger and a temperature probe rather than using a thermometer, because that gives us readings that are more precise to 1 decimal place for temperature rather than the whole number. So the thermometer would only read degrees of 10, 11, 12, whereas the temperature probes and the data logger can read to 1 decimal place, like 11.6 or 13.2, for example. The next questions relating to method 1 says, were your results repeatable? Now, most of the sets of results were repeatable because if you look back at the results, the energies that we got, each of the repeats that we did, were similar. There is one reading in the first set of results for spiky chili, which is a little different to the other 2 readings that were collected. So generally they were repeatable because the repeats came out similar each time, but we could comment on the one that was not. Were there any anomalies or uncertainties in the data? Well, here we'd say the second attempt for spiky chili crisps is an anomaly and should possibly be repeated again or not taken into consideration when doing your averages. Were you fully convinced about your conclusions? No, probably not, due to the anomaly that we saw and due to the inaccuracies in the measurement of temperature due to losing heat. Now to evaluate method 2. The same questions, but for method 2 rather than method 1. How suitable was this method? Well, I think this method was very suitable. They were actually using known data of energy densities, which avoids inaccuracies in any measurements that were taken because no measurements needed to be taken, and so therefore no causes of inaccuracy, and probably no ways to improve the method because it was just using calculations rather than taking measurements. Were your results repeatable? Well, no, they weren't, because we actually only took 1 set of data, and so therefore it's difficult to compare. No anomalies or uncertainties in the data though, although difficult to tell because there were only 1 set of results taken. We were more convinced by this set of data. And then the very last question says, did both methods give the same result? Well, no. In each of the methods, the data would suggest a different flavour. Method 1 suggested the spiky chili had the lowest energy per gram, and method 2 suggested it was sausage and bean, and this difference is likely to be due to inaccuracies in the measurements in method 1.